Uh, in this video, we will derive the atomic packing factor of HCP crystalline structure. HCP means hexagonal close-packed crystalline structure. So this is the uh, hexagonal crystalline close-packed crystalline structure. So in HCP structure, you can see that there are 6 atoms on the top. There are also 6 atoms along the faces on the bottom face. There is one central atom in the bottom face. There is another central atom on the bottom face, and then there are 3 atoms in the middle section. So this is the full view of the HCP, in which case the atoms have been shown as the full spheres. So if we want to find the atomic packing factor for HCP, so we know that atomic packing factor is atomic packing factor is the volume of the solids inside of the unit cell divided by the volume of the unit cell. Okay, so we determine both these quantities one by one. So volume, what is the volume of the solids? So volume of the solids means volume of these spheres. Actually Vs is the volume of the spheres. So volume of the spheres is can be determined by, first of all, we can determine the number of atoms in one unit cell. Okay, so these corner cells, they are total 12 corner cells, but each of this corner cell is about 1 by 6th involved in the unit cell. Okay, so that means first of all, number of atoms per unit cell. So there are 12 corner atoms, and each corner atom is about 1/6 associated with the unit cell, plus bottom and top, these atoms, they are 2, and then half of these are involved in the unit with the unit cell. So 2 times half, and then there are 3 middle atoms. These middle atoms are fully contained in this unit cell, so we will take their portion as 1. So in this way, it is 2 plus 1 3 plus 1 3 6. Total 6 unit cells are total 6 atoms are involved in one unit cell. Okay, and the volume of one unit cell is equal to, we already know that volume of one unit cell is equal to 4 divided by 3 pi r cube, where r is the radius of the sphere, and there are, as we have determined, there are 6 cells, 6 atoms in the unit cell. So it will be then 3 times 2 is 6, 8 pi r cube. So 8 pi r cube is the volume of sphere in the unit cells. So this quantity we have determined. So now what is Vc? Vc is the volume of the unit cell. Okay, so for the volume of the unit cell, we know that this you can determine that because this is the hexagonal shape. So hexagonal shape is continuous shape from the bottom to the top. So if we know the area of the base, then we know the height of the height of this shape, then we can multiply the area with the height, and that will be the volume. Okay, so volume of this cell is equal to base area times the height. Okay, so what is the base area? Base area is in the shape of this hexagon. So if you see that, I have drawn this hexagon over here. So this hexagon has 3 sides. So each side is equal to A. So this is by the definition of the unit cell. So each of the side is equal to A. And if you see this hexagon can be divided into 4 smaller shapes. Okay, and these 4 smaller shapes are divided like this, and each of this shape is a parallelogram. Okay, each of this shape is a parallelogram, and then from the property of the hexagon, we know that each angle is 120 degree. Okay, so if you want to find the total area of this base, so then we can take the area of this one parallelogram and then multiply it with 3. That will be the area of the base. So then this is equal to, so this area, so this base area is equal to 4 times the parallelogram areas. So 4 times the area of, so if I name this parallelogram as A, B, C, D, so this is the 4 times the area of A, B, C, D. Okay, so and times the height is this height is from here up to here, and then height is taken as C. So we don't know what is the height, but later on we will determine it. So height is C. So what is area ABC? So we need this area, we need this volume, as we have determined this volume in terms of the radius. Okay, so finally we need this volume in terms of this radius. So what is the area ABCD? Okay, so this area, if you focus on this area ABCD, then what you can do is this is the parallelogram, and we know that for the parallelogram the area is equal to the base times the height. So what is the height? So for the height, what we can draw a perpendicular, this from C up to B. So this is a 90 degree angle. We draw a perpendicular. So let's see, it is E. Okay, or you can say it's whatever. Okay, let's say it as E. So what is this height CE? Okay, so this we can determine by taking this angle. So what will be this angle? So this because as you can see that this is a regular shape, so we have joined this point P with the center of this shape, and due to the symmetry, this angle will be half of this total angle, 120 degrees. So it will be a 60 degree angle. 60 degree angle. And what will be this side? So this side will be also A. Why? Because we know that this AB is A, B, and this side is also A. And if we further join this by this point A with C, so this angle will be 60 degree. So if this angle is 60 degree, this angle is 60 degree, the other angle will be 60 degree. So it will be an equilateral triangle. So if it is in an equilateral triangle, so all the 3 sides of the triangle are same. So this side will be also A. So now we know this this side A, and from we know that CE over CB is equal to sine of 60 degree. So from this relationship we can find the value of CE. Okay, so area, so then what we can see is area ABCD is equal to A times the length CE. Okay, CE. And what is CE? CE is equal to we know that CB sine 60 degree. Okay, CB sine of this angle 60 degree. And what is CB? CB is equal to A. CB is equal to A, and sine of 60 degree we know that is under root 3 square root of 3 by 2. Okay, so it is then area ABCD will be A times CE. So area area will be then a times under root 3 by 2, under root 3 by 2. So it will be a square under root 3 by 2. Okay, a square under root 3 by 2. Yeah, there is one correction. This base area is not 4 times area ABCD. It should be 3 times, because there are 3 parallelograms over here. Okay, so VC is equal to 3 times area ABCD, which is a square under root 3 by 2 times C. We know that A is equal to 2R. A is equal to 2R. Why? Here you can see that this is these two atoms show the sides. Okay, so this each side is 1. Each side is equal to A. So A is equal to 2R, because the radius of this atom is R, radius of the other atom is also R. So A is equal to 2R. Okay, so we can put A is equal to 2R in over here. So then this will be 3 under root 3 by 2 A square, that means 2R square C. So 3 under root 3 by 2 4R square C, and so it will be 2, so it will be equal to 6 under root 3 R square C. Okay, so now we have to find the value of C in terms of R or in terms of A. So for this we can consider this base. So this is the outline of the base, okay, of this HCP structure, outline of the base. And you can see also that you can divide this base into these 6 equilateral triangles, and the just take this equilateral triangle. So for example, if this is the triangle, if corresponding to here is A, B, and then if it is C, so C is the atom in the center base, this atom, yeah, this atom. A is this atom, B is this atom. Okay, and there is another atom over here which we call as F. Okay, what is this atom? This atom is this in this shape. So it means that, and or if you can see that this is in this shape over here, this is A, this is B, this is C, and this atom will be F. So so you can see that F atom will be resting on these 3 A, B, C atoms. Okay, so now I draw another triangle. Okay, so what is that triangle? So in relation to this figure, I draw a triangle which is with the base and with the height and with the diagonal. Okay, so this I say as A, and this is F, and so you can see that the F is the middle atom, and this will be the point directly under F. Okay, so I call this as G. So in this case the length AF is equal to 2R. Because if you see that this is A, this is F, A and F are touching with each other, and then These are two atoms, so the radius of this is r, the radius